guys, welcome back to my channel. Now we'll be solving questions for Unibane engineering or physical science students, those that offer the course Physics 101. Not just Unibane, any university in Nigeria, even O-level students offering physics, these questions are pertaining to you. Now, in Phys 101 textbook, chapter 3, question 1, it says, as shown on the screen, a car starts from rest, accelerates at 2 meters per second squared for 15 seconds. It then continues at a steady speed for further 25 seconds and decelerates to rest in 5 seconds. Now we are asked to find the distance traveled in meters, question 1, 2, the maximum velocity, 3, the average velocity, and 4, the time taken to cover 2/3 of the distance. Now this question is coming from velocity time graph, which is a very basic topic we did in O-level physics. Now we're going to start by drawing a diagram and then before we solve the question. So for a VT graph, you have your y and your x-axis. Your y and your x-axis. The y-axis represents the velocity in meter per second, and the x represents the time in seconds. Now, since the car starts from rest, it means we're starting from origin. At origin in our graph, we have 0, 0. So the velocity is 0 at time t equals 0. So we start from rest and accelerate. For acceleration, we have an upward slope. An upward slope gives us acceleration. So this slope is acceleration. For how many seconds? How many seconds did you accelerate for? For 15 seconds. So we have 15 seconds on the time part. And then we can find the velocity. Why? We were given the acceleration as 2 meters per second squared in the question. Now, what then would be the velocity? Recall, v can be equal to u plus at. v equals u plus at. What is u? U is initial velocity, a is acceleration, t is time, and v is final velocity. Recall that the car starts from rest, meaning u equals 0. So if u is equal to 0, it means v equals to at. So therefore a is 2 and t is 15. Therefore v equals 2 times 15, which should give us 30. So we have 30 meters per second as the velocity. Now it then said it continues at a steady speed, meaning it maintains 30 for a further 25 seconds, meaning 15 plus 25 should now be equal to 40 seconds. Okay, 40 seconds. Now it then decelerates, meaning a slope downward. Okay, decelerates in 5 seconds. We will have 45 seconds here, and we are asked to find the questions there. Now this is the VT graph. Now question 1 said find the total distance traveled. The total distance traveled is gotten from the area under the graph. The area under the graph. Okay, so looking at the graph, which shape is shown to us from this graph? It is a trapezium. Many persons can decide to break the shapes down and solve for the individual areas, but you can solve it as just a goal because it is a trapezium. So the area of a trapezium, we all know from mathematics, is half sum of parallel sides times height. Half sum of parallel sides times height. Now what are the parallel sides here? The top and the entire bottom are the parallel sides. Now what distance do we have on top? Remember, it was 25 we added here, so we're going to have 25 here. And while the bottom, we have 45 for the bottom. So we're going to say 25 plus 45. as our parallel sides, then times what is the height? The height of the trapezium is 30. We're going to have 30 over here. So therefore the total distance traveled should be half times what is 25 plus 45. That looks like 70, and then times 30. So 2 into here 1, 2 into here 15. So what should become our answer? 7 times 5, 35, put on 5, carry 3, 7 times 1, 7 plus 3, 10. So we have 1050 meters for the total distance traveled. Now, what was number 2? We'll be asked to find the maximum velocity. What is the maximum velocity? Very simple. It is the highest value of velocity you have on the y-axis, which on the diagram is just 30. So our maximum velocity is just equal to 30 meters per second. Now question number 3 says calculate for the average velocity. Recall, average velocity is equal to total distance traveled over total time taken. Now what is the total distance we just calculated? 1050 over, check the graph, what is the entire time taken? It is 45 seconds. So we're going to divide that on the board. Now how do we divide that value on the board? What is 1050 divided by 45? Now this would give us what is 1050 over 45? 1050 over 45 should give us 23.333. So say 23.33 meters per second. This becomes the average velocity. Now, question number 4 said, calculate the time taken to cover through 2/3 of the distance. Now, we are looking for the time taken to cover 2/3 of the distance. What is the distance? The distance is 1050. We're going to apply the formula in number 3 to solve this question, because the average speed is the same for the entire journey. We're going to use the average speed to get our equation. Okay, so average speed is 23.33. Now our distance is no more the total distance, but 2/3 of the total distance. We will have 2 over 3 of 1050, and we are looking for the time taken. Okay, so we're going to solve this by cross multiplying. When we do that, t should be equal to 2 over 3 times 1050, all divided by 23.33. So let's check that out. Okay, so divided by 3 times 1050, all divided by 23.33. So the answer should be 30.004. That's like saying 30 seconds. Okay, so the time to cover 2/3 of the entire journey is just 30 seconds. And this is how you solve a question for velocity time graph. Moving on to the next question. Question number 2, as displayed on the screen. It says the displacement of a body in the positive x direction is given as x equals 3t cubed plus 2t squared plus 4t plus 5. Find the velocity and acceleration of the body after 5 seconds. Now quickly, just for remembrance sake, take note, velocity is actually the x over the t, while acceleration is the v over the t, or the squared x over the t squared. Meaning, to get velocity, you're going to differentiate displacement once, while to get acceleration, you differentiate velocity once, or you differentiate displacement twice, the second derivative. Now, what was the displacement in the question? We were given 3t cubed, okay, plus 2t squared plus 4t plus 5. Now, how do we differentiate our mathematics scholars? Remember, if you have y equals ax raised power n, then the y dx must be use the power n to multiply the entire function and then subtract 1 from the power. This is how you differentiate. So we're going to apply that to these patterns. So the velocity should become dx over dt, which should be 3 times 3, 9, 3 minus 1, 2, 2 times 2, 4, 2 minus 1, 1, 1 times 4, 4, 1 minus 1, 0. So I have just 4 here, and then there's no t here, so let that be. Okay, so therefore our velocity is this. Now remember, they said after 5 seconds, meaning we can find the actual value for v, meaning anywhere you see t, put 5. We're going to have 9 into 5 squared plus 4 times 5 plus 4 again. Therefore, the velocity should become 5 squared is 25, 9 times 25 should give you 225 plus 20 plus 4 plus 24. And the answer becomes 249 meters per second for the velocity. Now, how do we get acceleration? It is dv over dt or d squared x over dt squared, which means we're going to differentiate this function again, which becomes the second derivative of the initial function. So let's apply the same pattern again. So what's 2 times 9? 18t. 2 minus 1 is 1. Then we have 1 times 4 is 4. 1 minus 1 is 0. 4, there's no t here. We'll let it be. So we have 18t plus 4. Recall again after 5 seconds. So therefore, a becomes 18 into 5 plus 4. Okay, so we have 18 times 5 plus 4. 18 times 5 should give you 90. So we have 90 plus 4, and that equals 94 meters per second squared. So that gives you the acceleration of the object after 5 seconds. Moving on to number 3. Question number 3, as displayed on the screen. It says, a ball is thrown vertically upward, returns to the thrower 4 seconds later. Determine the speed determine the speed with which it was thrown. Sorry about that. Okay. Determine the speed with which it was thrown. In brackets, g equals 10 meters per second squared. Now, how do we solve this question? It is a vertical motion question. I'll show you a diagram just for easy understanding. We have a platform. We're throwing an object, and it's to come down back to this same path. So we have an upward motion and a downward motion. I'm sure you agree with me that when this object leaves the ground, the initial velocity, I think that was given, it wasn't, but the initial velocity is going to be maximum. Okay, for an object to leave the ground, the initial velocity will be maximum. Now you also know that the point where the object returns from traveling upward, we call that the point in mathematics, the point of inflection, the turning point. At the turning point, the final velocity must be equal to 0. The velocity in the y must be equal to what? 0. Okay, so you can break this motion into 2 parts. What you have here and what you have here will be equal time taking. So the time to move up and the time to move down will just be t, meaning the total time taken will be 2t. We were given the total time taken as how many? As 4 seconds. Okay, so we can find the time to reach maximum height, which is small t. So small t becomes big T over 2, 4 over 2, which is 2 seconds. Now, since we have the time to get to the maximum height, we can apply the equation of motion, which says the velocity in the y-axis equals to the initial velocity in the y-axis. Since I'm moving upward, I'm going to apply minus gt, where this t is the time to reach maximum height. Recall, at maximum height, Vy equals 0. I'm going to put 0 here, and then we are looking for Uy minus, we're giving G as 10 in the question. So we have 10 times, what is T? 2. Remember, T is not 4, but 2 because we are considering maximum height. So it's half the time. So collect like terms, we're going to have Uy to be equal to 20 meters per second. So the ball was thrown with 20 meters per second. Number 4, it says, as shown on the screen, it says a train approaching a terminus does 2 successive motion, 200 meters in 10 seconds and 15 seconds respectively. Assuming the retardation to be uniform, find the total distance the train runs before coming to rest. I'm going to give you a diagram for easy understanding. Okay, so we have a point A, a point B, and a point C. So the train does 2 successive motion, A to B and B to C. Now A to B was done in how many seconds? In 10 seconds, while B to C was 15 seconds. And the distance for A to B was 200 meters. Likewise, B to C, 200 meters. Now, how do we solve this question? We're asked to find the total distance traveled. Now, many of you might be tempted to say the answer should be 400, but that's a lie. When you apply your brakes, the car still moves a distance further before coming to rest. So there's going to be an extra value. So the answer should be around 400 and something. Okay, it should be above 400, but it cannot be below 400. How do we solve that? Let's get the initial velocity and the acceleration, or rather the deceleration, because it is coming to rest. What do we then do? We need to bring out 2 equations because we have 2 unknowns. Okay, so we're going to solve for A to B, and we're going to solve for A to C. Now, I did not solve A to B and B to C because that will be discontinuous. To form your equations, you need a continuous equation. So A to B and A, the same A to C, will work that for us. So from A to B, I'm going to be applying the formula that says the final position minus the initial position equals initial velocity in the horizontal times t plus or minus half a t squared. Now, since the object is going to rest, we're going to be using minus here. Now, final minus initial actually means the distance. So what's the distance between A to B? That's 200. So we're going to say 200 equals, we don't know ux, but we know t. T is what? 10. So we can say 10u minus half at squared. T is 10 again. What is 10 squared? 10 squared is 100. What is the half of 100? That gives you 50. So we have 50a. Now we can take out the zeros. So 0, 0, and 0. We then have 20 equals u minus 5a. We can make u the subject of formula. We then have u to be equals 20 plus 5a, equation 1. Now moving on to equation 2, a to c. Remember, a to c. On the diagram, a to c is 200 plus what? 200, and that's 400. So we're going to have 400 equals, now the time for a to c becomes 10 plus 15, and that's 25. We're going to say ut, that is 25u, okay, minus, what is 25 squared? 625. What is the half of 625? 312.5a. I'm sure we can divide all through by 25. Now we can divide all through by 25. 400 divided by 25 gives us 16. We have 16 here, and then we have just a u here, and then 312.5 divided by 25 gives us 12.5. We have 12.5a. Now we can again make u the subject of formula. We're going to say u becomes 16 plus 12.5a, equation 2. Equation 1 and 2 have u and u. Therefore, we can equate the u's to get an equation. Okay, we're going to say 20 plus 5a equals 16 plus 12.5a. Collecting like terms, let the 16 come here and the 5a go there. So we have 20 minus 16 equals 12.5a minus 5a. What do we have here? 4 equals, what is 12.5a minus 5a? That gives us 7.5a. How do we get a? We're going to divide both sides by 7.5. So we'll now say a becomes 4 divided by 7.5, and that should give us 0.533 meters per second squared. Remember, it is retardation because we applied minus while solving. If you had used plus to solve, you're going to get a negative answer that depicts retardation. Now we've gotten a, we can as well find u. We can find u from either equation 1 or equation 2. I'm going to apply equation 1. So we can say that u is equal to 20 plus 5, open a bracket, 0.533. So u should become, let's solve that quickly, not to waste time. Okay, plus 20, 0.533. So u becomes 22.67 meters per second. This is the value for u. Now we've gotten a and we have gotten u. And we are basically asked to find the total distance it travels before coming to rest. Now, how are we going to go about this? Moving on. Remember, going to rest, the final velocity must be equal to 0. So we call v squared equals u squared minus 2as. I'm using a negative sign because it is retarding, it is decelerating. So therefore, if v is 0, we have 0 squared equals u squared minus 2. Now what is the acceleration? It is 0.533 and then times s. But we know what u is, right? Yes, u is 22.67 all squared. Okay, so 0 squared becomes 0. Now what is 22.67? 22.67 squared becomes 513.9289. Okay, minus 2 times 0.533, that gives us 1.066s. Okay, we are solving for s, so we take this value up to the left hand side, it becomes positive. We then say 1.066s equals 513.9289. We divide both sides by 1.066, here by 1.066. Cancel. The total distance traveled should become 513.9289, divided by answer should become 513.9289 divided by 1.066. 482.1 meters. Okay, so this is the total distance traveled by the object. Moving on to the next question, number 5. Question